For this video, I will show you how to be able to get and see the shadow prices using the Microsoft Excel solver. Um, Let us go back to our previous example, the first time I showed you how to use Microsoft Excel solver. And in this case, I was using the red blue gadget problem. Okay, so if you remember this model, this Excel worksheet model, we've inputted the red blue gadget problem, and all we have to do is to solve it using solver. What I have here now is the Excel model. So we want to set the objective to be D3, and we'd like to maximize D3. And then for the variable cells, we'd like to set B2 and C2 to be our variables. And for the constraints, we want D4 to be less than or equal to D4 until D6 to be less than or equal to F4 until F6. Again, we make sure that unconstrained variables are non-negative, and the solving method is simplex LP. Okay? Now all we have to do is press solve. Okay. So after the solver add-in was able to solve the linear programming model, you will have this dialog box. Please do not press OK, because pressing OK will exit the dialog box. What we need to do before pressing OK is to click on this part of the dialog box. As you can see, there are 3 reports that are available. And for our lesson, we will just need the answer report and the sensitivity report. So please click these 2 reports before pressing OK. After pressing OK, Excel will be able to automatically create these 2 worksheets, the answer report and the sensitivity report. Okay, so clicking on the answer report, it will give us a preview of all the information that we need on the answer to the linear programming model. So let us go through each of them one by one. This part of the answer report tells us the final value. We don't need the original value. What we need is the final value. And this final value tells us the optimal objective function value of our model. So the maximum profit for the red blue gadget problem in this case is 295,000. For this part, again, we will be able to see that x1 has an optimal value of 500, x2 has an optimal value of 150. This one here just tells us that the variable x1 and x2 are continuous variables as opposed to integer variables. It just so happened that the optimal solution is an integer, but because x1 and x2 are continuous variables, technically you allow them to have decimal values. And finally, for this part of the answer report, let's try to understand what information it is giving us. So let's look at this first row first. So the first row pertains to our steel supply constraint, and the left-hand side value of your steel supply is 1,000. What do we mean by the left-hand side value of steel supply is equal to 1,000? Let's go back to the Excel model. As you can see, our steel supply constraint is represented by this left-hand side, and the formula is the sum product of B4 C4 until B4 until C4, comma B2 until C2, which means we are multiplying B4 with B2 and then adding it to C4 multiplied by C2. So as you can see, because the value of x1 is 500 and the value of x2 is 150, if you get the sum product of 2x1 and 0x2, the value, in this case the left hand side, is equal to 1000. Okay? And that is what this cell value means. Now, because the left-hand side is 1,000 and the right-hand side is 1,000, then that means there is no excess steel in our supply. Naubos. And therefore, in the answer report, you will see a status of binding. What does a status of binding means? It means that there is zero excess. And in this case, you can see excess under the column slack. So slack technically is how much in excess or how much excess do you have for that particular constraint. And in this case, we're talking about steel supply. In the same way, if you look at constraint 3, the cell value is 1,800 because 3 times 500 plus 2 times 150 is equal to 1,800. And because the right-hand side is 1,800, then that means slack or excess is also 0. And therefore, the labor supply or the labor constraint or the labor resource is binding. Conversely, if you look at the wood supply or your wood constraint, 0 times 500 plus 2 times 150 is equal to 300. 300 is not equal to 1,200. In fact, it is less than 1,200. So what does that mean? You only used up 300 wood, and therefore, because you have 1,200 supply of wood, then you have an excess of 900. Because there is an excess of 900, therefore slack is 900, and therefore the status is not binding. So in this case, to summarize, if your slack is 0 or if you don't have an excess, then the status of the constraint is binding. If you have a slack or if you have an excess, then the status is not binding. Now, before we conclude the discussion for this answer report, let us try to understand what binding and not binding means. So what does binding mean? We have to in order for us to understand what binding means, we have to understand when is a constraint binding. A constraint is binding if the slack is 0 or if excess is equal to 0. So what does that mean? Because your excess is equal to 0, your model, your optimization model is being binded, being limited by this constraint, by the steel constraint. In the same way, your optimization model is also being binded, being limited by your labor supply constraint. And what does being binded or by being limited by the constraints mean? It means that if you have an opportunity to increase your steel supply and or your labor supply, and because you are binded by these constraints, that means any additional supply to these two constraints will actually mean more profit for you. It will give you benefit, additional benefit if you are able to increase your steel supply and labor supply. Conversely, because your wood supply constraint is not binding, therefore your optimization model is not binded or not limited by your wood supply constraint. That means if you are able to increase your wood supply, then that will not give you any additional benefit. And I hope that is very easy to understand. The fact that you have 900 excess wood means that if you are able to increase your wood supply, then walang kwenta yon. There's no additional benefit to you. in the first place, you actually have an excess of 900 already. So what more if you have additional wood? Conversely, because you don't have excess in steel and labor supply, any additional steel and or labor supply will provide additional benefit to you. And I think, I hope that with our discussion on shadow prices, you now understand that the additional benefit to you is represented by the shadow price. Which brings us to our sensitivity report. Now, for the sensitivity report, there will be two tables that will be generated by Excel: the table for your variable cells and the table for your constraints. For our purposes, we will only focus on the table for the constraints because that is where we will see the shadow price, as you can see. Okay? Um, The table for your variable cells will contain certain information that is needed. And in this case, for our purpose, we will only need column D and column F. The final value being the optimal value of your x1 and x2, which is already available here, 500 and 150. And the objective coefficient 500 and 300, which is also available in your model, which are these values. Okay, so essentially we don't need the table for variable cells. So in that case, we can move on to the table for their constraints. Now let's try to understand the table generated by the sensitivity report. As you can see, the table shows us the three constraints in the model: your steel, wood, and labor supply constraints. The final value again are the left-hand side values. So these are your 1,000, 300, and 1/8, the amount of steel, wood, and labor used. The constraint right-hand side are just these, the right-hand side values of your constraints. And of course, your shadow prices, 25, 0, 150. Furthermore, you will be able to see your allowable increase and allowable decreases in your per constraint. No? So if you remember our discussion on the steel supply, our steel supply shadow price is 25, and this shadow price of 25 is effective up to an increase of 200 steel, or an allowable or up to a decrease of 600 steel. In the same way, for wood, you are allowed to decrease your wood supply by 900 and the shadow price is still 0, or you can increase it indefinitely or infinitely. 1e plus 30 is Excel's way of showing infinity in this case. Finally, for labor constraint, you can increase by 900. So from 1,800, it can go up to 2,700, or it can also go down down to 1,500, and your shadow price is 150. So as you can see, you don't have to solve. So as you can see, you don't have to solve the shadow prices and the allowable increases and decreases manually, because Excel Solver will be able to produce them instantaneously.